Hello, welcome to Technoveda Solutions. In this video, we will discuss about pointers and we'll see how do we access pointers and how do we use pointers and what are the different types of pointers we have. Okay, let's begin. So let's first understand what is a pointer. Pointers are variable that stores the memory address of other variables. That means the pointers will always store the address of variables, and we know that address of variables will be a memory location. That means we can say that pointers will always store a address in the memory block or the memory address. And we should also remember that as it is storing the address of a memory, irrespective of the data type what is defined, the pointer size will be same. That is whether we define an integer pointer or a character pointer or any other type of pointers, the size of the pointer will be same for a given memory model. Then the value of the variable can be modified using pointers. So we'll see how to do that. How do we dereference pointers to access the value stored by the variable which it is pointing to. So when we want to declare a pointer, we use a symbol asterisk. So that symbol indicates that the variable what we have defined is a pointer and not a normal variable. So here's the syntax you can see here. First we have to define a data type, then the name of the pointer. So I have given ptr as a name of the pointer. You can give any name here. Prefix to that you need to give a asterisk symbol that indicates that this particular variable is a pointer variable and not a normal variable. If I don't give this asterisk symbol, then it becomes a normal variable which stores the value, whereas when we give the asterisk, then it is a pointer. That means now it will store the address of a other variable or the memory location. So that becomes the name of the pointer. So we have data type of the pointer and this is name of the pointer. Now it should always point to the same data type of the pointer to which it is defined as. That means if I define an integer pointer, then that pointer can point only integer variables. If I define a character pointer, that can point only character variables. So the data type of the pointer and the data type of the variable to which it is pointing, both should be same. Okay, here we can see how exactly pointers actually work. So this is one variable having an address. For example, 1000 is an address which is the hexadecimal number, and in that memory location we are storing the value 10. So this is a variable having address 1000 and storing a value 10. Now if we declare a pointer and we assign this pointer to this variable, that means this pointer should be having a address of this variable. Now when we declare a pointer, a memory location is created for that, or a memory is allocated for that pointer. Now in that memory we store the address of this variable. The pointer will also have a separate address, but in that memory location the content will be the address of this variable. So when we want to access this value of this variable, we will be dereferencing this pointer. So it will go to this address and it will fetch the value stored in that. Similarly, we can create a pointer to pointer like this, that is a double pointer. So that means we create another pointer. So another memory allocation will be happening for this pointer. Now this pointer will be storing the address of another pointer. So this pointer address will be here. Now this pointer is pointing to this pointer. So it is called pointer to a pointer. And we can dereference this twice to get the value of this variable. Okay. This is how actually a pointer work. How are the pointers used? So let's start with a very simple examples. So first we have to do a pointer declaration. So for declaring a pointer, we use the asterisk symbol. So when we declare the pointer, no variable address is assigned if it is not initialized. Now you can see this, we are just declared a pointer here and I have declared the variable here, but this pointer is not assigned anywhere. That means right now it is not storing the address of any variable. It's just a pointer is declared. Then the next step is initialization. That when we initialize the pointer, that means we store the address of a variable in the pointer. Now this ampersand symbol what we see here, that means it's the address of this I will be stored in this variable called pointer. Now pointer will have the address of this variable I. Then we have to access the value of the variable to which it is pointing, we use dereferencing. Again for dereferencing we will be using a asterisk symbol. So usually whenever we read, generally to understand what we are reading, here whenever we come across the ampersand, we say address of the variable what we may mention there, and when we give asterisk symbol, we read it as a value at this pointer. Okay, so that is value at the pointer that will be printed. We'll see that how that works. Now we'll before getting to code, let's understand different types of pointers in C programs. So first one is integer pointer. So pointer to a primitive data type such as integer, character or a float. It can be any type. So I have just taken as one integer pointer just instead of just writing a pointer. So this can be a character pointer, this can be a float pointer. Basically this category deals with the primitive data types or the basic data types. So we define the data type which pointer we want to declare, and then the pointer variable with the asterisk symbol. Similarly, we can have a array pointer. Array pointer means it is a pointer which is pointing to an array. Okay, so pointer having the address of an array, or it is pointing to an array. And always remember, the name of the array itself is a pointer. That means the name of the array is an implicit pointer storing the address of the first variable of the array. Again, I will discuss about this in detail when we talk about the arrays. So just now we will remember that when we say array pointer, it is pointing to the array. That means it will store the address of array, and array name is an implicit pointer. So as we store the address in the similar way, that is pointer data type, pointer, and the address of the array name. So that will be pointed to this pointer. Then we have a function pointer. So then when we say function pointer, these pointers will be pointing to a function. So to define a function pointer, first we write the return data type, then the pointer which is pointing for the function, then the function name, and then the parameters or the argument list. So this pointer is defined as a function pointer here. Okay, pointing to a particular function. So we can change the function also. We can point this function pointer to a different functions in the program. That is also possible. Similarly, we can have a structure pointer. That is the pointer which is pointing to a structure. So for that, we create a struct as a keyword, then the structure name and the pointer of that data type. Then this pointer will become a structure pointer. Especially this type of structure pointers we use in linked list and all the data structure operations, we use structure pointers. So that we will see when we go for the data structures. Next we have file pointers. So these pointers will point to a particular file whenever we want to do a file operations, read the file, write the file, edit the file. So we have different operations which can be performed on the file. So that also we'll discuss later in detail. So we'll declare the pointer of a file type so that we can use that pointer to file to a particular file variable or the file data type. Then we have something called as the double pointers. So double pointers are the pointer which is pointing to another pointer, that we call as a double pointer. We declare a pointer variable which is pointing to another pointer instead of a variable. If we say just a pointer, then it is pointing to a variable directly. But when we say double pointer, it is a pointer to another pointer. So like that, we can have any number of pointers in the consecutive list. That is, we can have a triple pointer, quadruple pointer. Like that, we can have any number of pointers. Okay. Then we have one more thing called as a null pointer. Null pointer means it is not pointing to any of the memory locations. So we just say data type pointer, then we assign it to a null. That means it is a null pointer. So as and when we go for higher operations, I will explain you about this when we come across these operations of these null pointers. Similarly, we have void pointers. Void pointers are not associated with any data type. So that means we can define a void pointer and later we can decide which pointer it should be typecasted to. We can typecast it to any of the other data types. So usually what happens, some of the implicit functions will return void pointers. Definitely when we go for the dynamic memory allocation, we will see that, and how do we use a void pointers in those cases. Then we have something called the wild pointers. Wild pointers are declared pointers, but they are not yet initialized. Only declaration of the pointers. That means that is a not pointing anywhere this right now. So it will be a wild pointer. Later we have to assign the address of another variable. That is wild pointer. But remember, null pointer is different and wild pointer is different. Null pointer cannot be reassigned to anywhere, but this wild pointer is be reassigned later to another variable. Only during the declaration time it will be a pointer. Then we have a constant pointer. The constant pointer will store the address that cannot be changed. That means the address which is stored in this particular pointer variable cannot be changed. It is going to point to the same location. We cannot change the address of that particular pointer variable. So that we call as a constant pointer. Similarly, we have pointer to constant also. In this case, the value stored at the address stored in pointer cannot be changed. Here address itself cannot be changed, but in this case, that is pointer to constant, value cannot be changed. I repeat, in constant pointers, address of the pointer cannot be changed. In pointer to a constant, the value of the location to which the pointer is pointing, that cannot be changed. So here we first define the data type and then the constant keyword, then the pointer name if we want to declare constant pointers. If you want to declare a pointer to a constant, first you have to give a constant keyword, then data type, then the pointer variable. So that's the difference between constant pointer and pointer to a constant. Then we have something called the dangling pointer. Pointer pointing to an address that is already deallocated. Initially it was pointing to a particular location. That location is deallocated, but pointer is still existing in the program. That means it will be a pointing to a memory location which is already deallocated or which is not existing. So that is dangling pointer. That also we'll discuss with the application when we go for the virtual functions. Especially when in C++ we can understand this better, but in C also we come across such issues. Then we have pointers based on the memory model. Till now, whatever the pointer we discussed, they are all compiler based pointers. So these three pointers are based on the memory model. The first one is near pointer. So near pointer is a 16-bit wide pointer and can address only within the particular segment. Already we have discussed what a segment in first couple of videos. You can watch those videos. I will give the link in the description box. That's in the programming model. We have discussed what is a segment and how the segmentation is done and what is stored in each segment. So here near pointers are the pointers which can address only within the segment. Then we have something called the far pointer. So these pointers are used when we want to address the location outside the segment. So these are 32-bit wide pointers. So we can point to the memory location outside the current segment of the operations. So they are far pointers. Similarly, we have a huge pointer. So this huge pointer is also a 32-bit pointer, but this has a segment base address and an offset address. This pointer will have two addresses. A part of that will be a segment base address, and part of that will be an offset address. So we have to add the offset address to the segment base to get the actual address. That is huge pointers. Okay. So now we will go to the code to check how these pointers actually work in the program. Okay, coming to the code. So first we declare the header file, then the main function. So in the main function, first we have declared the pointer of integer data type. However, we can use any data type here. So for explanation and easy understanding, I am starting with the integer pointer. So we are using a variable name as a ptr with the asterisk symbol that indicates it's a pointer variable. This is a just a variable declaration, normal variable, so we don't have asterisk symbol, it's just a variable name that we are assigning to value 10. Then we have another pointer that is a double pointer. We can observe here there are two asterisk symbols, that means it is a double pointer. Then we have uninitialized pointer. I'm just creating a pointer but not initializing anywhere, that means this will be a wild pointer, which is not assigned anywhere. It's similar to that. Then I'm just declaring another pointer of the void type, so that means this is a void pointer. So we can assign that to a any data type later. Here while declaring, I'm declaring as a void. Later I will decide whether it should be a character pointer or integer pointer, that we can decide later. So while declaring, we are just declaring a pointer as a void pointer. That's the advantage of that. Then when we want to initialize, here you can see pointer is initialized to val. Remember, when we are assigning a pointer, that means we have to assign the address of the value or the variable. So here you can see the ampersand symbol that indicates address of val is stored in pointer. Similarly, address of val is stored in pointer 2 also. Here I am assigning the value. Actually this pointer 2 was a wide pointer, but now I am assigning it to the integer. Now it becomes an integer pointer. Then we have a double pointer, that means it's a pointer to another pointer. Already ptr itself is a pointer. Address of that ptr we are assigning it to the double pointer. So this double pointer will store the address of this ptr. Okay, that's a double pointer. Then now we will dereference them and see what output we are going to get, and let's understand each of the output. So let's compile the code. Okay, so code has been compiled successfully without any errors. So let's come to the beginning of the output. So let's see what output we are getting, and let's understand how the pointers are working. So the first one is just printing the value, the content of that using %d. So value we have assigned to 10, so it will print 10. Now you can see here, this is a pointer dereferencing. So pointer we have pointed to val. So value at pointer, that means it is a value stored in val variable. So that variable we are declaring the value stored in that variable or printing that here. So this will also print 10, which is stored in val. Similarly, we have another double pointer pointing to this pointer. Now we are dereferencing it 2 times. That means first dereference will take it to the ptr, second dereference will take it to the val variable. So when we give a 2 asterisk symbol, it will print the value stored in the val variable. So that is also 10. So you can see that in all the 3 print statements, we are getting the value assigned to this val variable. Val variable. Okay. Now suppose if instead of dereferencing, let's see if we directly print, what do we get. Now if you see here, we know that this is the address of, whenever we give a ampersand, that means it is the address of. So here I am trying to print the address of this val using a %d format specifier. So it will print the address of that. This is the address of that variable val. Now if I print content of this ptr, only if I give ptr without asterisk or ampersand, means what? It is a content of this ptr, that memory location. So the content of ptr is address of val, that because pointer has to point to the val variable. So this will store the address of this val variable. So if I print the ptr, that will also give me the address of the val itself. Okay. Now if I dereference double pointer once and print that, that means again I am trying to print the content of ptr only. What ptr variable is storing, that only we are trying to print here. That is the single asterisk with double pointer. So that will also give the same address. But now here one thing you have to observe, in the first 2 cases I give a %d, that means it printed the address in the decimal format. But here I have given that in the percentage x, that means the address is printing in the hexadecimal format. If you know how to convert from hexadecimal to decimal and decimal to hexadecimal, you can cross verify that both the addresses are same, only the base is different. This is hexadecimal equivalent and this is decimal equivalent. So if you want hexadecimal address, we will be putting percentage x. Then if I say address of pointer, that means now what it will give, it will give me the address of this pointer. If I give only ptr, it will give me the address of val variable. If I say ampersand ptr, it will give me the address of ptr. This will give me address of ptr variable, that is pointer variable. Whereas if I only print ptr, this will give me address of val variable, right? Then if I only print dbptr, it will give me the address of ptr again. So here we can see that here we can see when I print just ptr, it is giving me the content of that ptr, that is address of the val. Whereas when we say db ptr with a single asterisk, it is giving me the address of pointer variable. So that is 61, this address 61FF10. Again, if I print the content of double pointer which is pointing to this ptr, that will also give me the same address. So double ptr is pointing to this ptr is pointing to val. Now while dereferencing, we have to decide how we want to display the output or what we want to display the output. Depending on that, we can access the addresses or the value of a pointers which are assigned to one another. Okay, now we will also look into a pointer arithmetic, how the pointer will be incrementing, decrementing, what will happen in those cases. Now here we are printing the value of the pointer, that means the val variable with the increment, but the value assigned is 10, we know that. But when I try to print this, it is giving me a 10 as output, but I have given an increment here. But we have to observe that this is called post increment. So this increment operation will be performed after printing. Okay, that is post increment. So it will first print the value, then it will increment. How do we know whether it is incremented or no? Then in the next instruction, I am just printing this pointer with the dereferencing that. That means it will print the content of val variable now. See, you can see that has incremented to 11 here. In this instruction, it has incremented to 11 because in the previous instruction we have given a post increment. So it has incremented by one value. Then if I want to increment and print, then we can give in the same instruction with a pre-increment. So we are giving plus first and then the dereferencing the pointer. That means first it will increment the value and then it will print the value. So this is post increment, this is pre-increment. Okay, then we see how the addresses will change with respect to the different pointers. So now if I just give a pointer increment, okay, ptr, I am incrementing that. So you can see that it is printing the address 642284. Now here it was 642284. The same address is printed here. Why? Because again this is a post increment. So it will print the same address. Now if I see the address of the pointer now, okay, the address of the pointer has been incremented. Now if I check that pointer, then we can see that it has incremented by 4 bytes. Now why it has incremented by 4 value? Because the pointer is of integer data type. Remember, the size of the pointer will be same, but increment and decrement of the pointers will happen based on the size of the data type to which it is pointing. we have to remember that. Okay, so if I increment, it will increment by 4. That is because integer is of 4 byte. The size of int is 4 bytes. So it is incrementing 4 values here. Then again, we are doing a pre-increment here. So first increment and then printing that. So that will again increment by 4 value. So we will get a 92 at the end. And we also have defined one pointer which is not initialized anywhere. Now if I try to print that, what will I get? I will get the address, and it is the value also. If I print, it will give some garbage value because we have not initialized this pointer anywhere, correct? So this is how the pointers will work. We can observe the variations in the different manner. We can change these things and check how the things will work. Okay, and with practice we will come to know how they are actually working. Okay, only thing we have to remember is the ampersand symbol will be address of, asterisk symbol is value at. Those two things are very very important when we are operating with the pointers. Okay, so we will discuss these things again when we go for different applications. So when we are dealing with the array, we will discuss about array pointers. When we are dealing with the functions, we will again discuss about the function pointers. Then with the structures, we'll discuss the structure pointers. So all those pointers we'll discuss one by one. I hope you liked the video. Please click on the like button, subscribe to the channel, and share with your friends. I'm also giving you a link of other playlist in the same channel. You can check out those videos as well, and comment which one you like most and which videos you would like to look at more frequently. Accordingly, we can prioritize the uploading of the videos. Thank you. Have a good day.